I'll be covering some specific topics because for this week we didn't have a code challenge. So I'll just be taking us through what we went through. That is from Monday until today. And then I believe after the end of our session, we are going to be maybe a step ahead, or even we are going to be better. So I want to welcome all of us to this session. Feel free to interact, feel free to ask questions. In case you feel that, I think I might have seen someone saying that they had maybe difficulties in understanding the concepts. And actually, you're not alone. Most of the people go through the same. Whenever you're learning something for the first time, there's always that feeling. There's always that feeling. So you're not alone. And what I can encourage you to do is to bruce yourself up, guard yourself, and yeah, let the grit, let the growth mindset drive you, because we are all going to be doing things together. So you can actually reach out to any of us. I think I've seen Velma. I have also seen, I'm not sure whether I'm going to be able to read this name correctly, but our host for today, please forgive me if I don't read your name correctly. It's Dapob. I'm not sure whether that is the correct pronunciation.
Honestly, I will give you a beautiful babe for you did well. A babe for you.
Okay, thank you. So we are all here, and you can reach out to anyone. In case you feel that things are too hard for you, kindly reach out to anyone, reach out to any of the admins, reach out to any of the facilitators, and we are going to help because we all work together as a community. So that is for, since the last time we were together, we've been able to cover this, or even we've been able to go through all this logic and loops in Python functions. And then for this week, we were also supposed to go through function parameters, PEP 8 principles. And then we also have OOP, that is object-oriented programming, advanced functions, algorithms, and complexity and analysis. So that is what we were supposed to go through for this week. But because of the time that we have, I'm not going to take you through all this because, it's really extensive, or even it's really comprehensive. So I'm just going to take you through a few of them. I'm going to take you through function parameters, and then PEP, and then object-oriented programming, and maybe we are going to talk about maybe the last two, that is advanced functions and algorithms and complexity analysis. That is if time is going to favor us. So without wasting a lot of time, allow me to just take you to that. Allow me to take you to that. I know most of you
I hope you will share this material with us when you are through.
Okay, there is no problem. I'm going to share the notebook with you guys so that you can just go through it. It contains everything about loops and everything about what you've been able to tackle so far. So this is what we are going to, this is where we are going to begin from. And in case for the facilitators and also the admins and any one of us, in case you feel that there is something that I've left out, kindly you can unmute and maybe remind me so that we don't leave things, or even we don't skip a few things. So function parameters. And under function parameters, we are going to be talking about arguments and keyword arguments, and also default arguments. The three. So we have arguments, we have keyword arguments, and then we also have default arguments. And from the word itself, function parameters, these are actually parameters that are found within all the functions, or even they are parameters that are found within a function. And maybe before I proceed further, let me just show you an example of a function. This is a function for your code 1 and also for your code challenge 2. You are able to go through different functions. So this is a function. This is a Python function. A Python function is or even it always begins with the DEF, define this one. So these are function. And then we have the function name, and then we also have the parameter in this case. So a function as the function name, we usually have the function name. For example, in our case there, the function name is analyze crop yields, and then we have the parameter. And then maybe we have now the variables. These are now variables. These are variable names. The average, the maximum, the minimum, those are averages. Okay, I mean, those are variables. So when you talk about parameters, we are majorly speaking about the inputs. In this case, what we input here, the inputs, those are now the parameters. So parameters are variables that functions accept as input. They are variables that functions accept as inputs. And we usually have three different types of parameters. We have three different types of parameters in this case. The first one is regular parameters. We have regular parameters. Regular parameters, they are fixed numbers of arguments in this case, like the ones that you are dealing with when you are actually dealing with your code challenge 1 and also code challenge 2. Most of the times you dealt with regular parameters. So we have regular parameters. We also have arguments. In this case, these are variable number of positional arguments. Args, these ones, they represent variable number of positional arguments. And we are going to dig deep into this as we proceed. Then the last one, the other one is keyword arguments. KW represents keyword, and then ARGS represents arguments. So keyword arguments, these are a variable number of keyword arguments, or even it represents a variable number of keyword arguments. So in this case, we are having two different types of arguments. We have positional arguments and we have keyword arguments. And as we proceed, I'm going to be giving you the differences between the two. What is the difference between a positional argument and a keyword argument? And then the last type of parameter is default value. And I gave you an example of a default value during our last meeting. For example, whenever you are calculating the area of a circle, you always have a default value, which is pi. Pi never changes. Pi is always 3.142 or maybe 22/7. So that is a default value. It never changes. So you can use that as a default input or even as a default parameter. So this one is a parameter with preset values. Even the values are usually set before coming up with the variables. So where do we use these function parameters? Where do we use them? These features allow functions to be flexible and accept different number of inputs. So these functions are actually used in most of the programmings, or even more whenever you're dealing with programming, you use these functions most of the time. And they allow us, or even they allow functions to be flexible. That is, you can work around with a specific function. So they make a function to be flexible. And apart from that, it also enables them to accept different number of inputs. Why are they important? They make functions more versatile to use and also easier to use. You can imagine with a default parameter or even a default value, you can be able to calculate the area of any circle of any diameter, because you have pi, which never changes, which is always 22/7. So in this case, they always make our functions to be more versatile and also easier to use. This is a general syntax in this case. For this case, I've come up with different syntaxes for different parameters in this case. So for example, we have a regular parameter. A regular parameter will accept different inputs in this case. That is a different fixed inputs, fixed number of inputs. For example, when we were discussing last time, we talked about maybe finding the area of a rectangle. When you want to find the area of a rectangle, then your first parameter will be the length and your second parameter will be the width. So in that case, for you to be able to calculate the area of a rectangle, you will just pick the length, which is the first parameter, multiplied by the width. So this is a regular parameter. These are regular parameters in this case. They are regular parameters. You can't add them. You can't find area of a rectangle by having more than 3 values. You only need 2 values. That is the length and the width. So those are regular parameters. And then we have now default parameters. Default parameters. Now, for this case, assume you want to find the area of a circle. You want to find the area of a circle. Assume you want to find the area of a circle. So in this case, your first parameter will be the radius of that circle. And then the second parameter would be now the pi. And pi would be default. You just replace parameter 2 with pi. Pi is equals to, and then you enclose your 22/7 within the double quotation marks in that case. So this is default. It is a value that never changes. And I said, whenever you have a default value and then you don't use that value, or even that, in our case, you substitute the default value within the variable, then the output will not have the default value. Assume you are having something like this. Let me just add a cell. Let me just add a cell somewhere. So assume you had something like this. So in our case, we are having this. Let me just copy this. Copy. So we have our function in this case, which accepts parameter 1. Parameter 1 will be our radius. And then parameter 2 will be our pi. So pi is equals to 22/7. 22/7. 22/7. So what is to be returned in our case? What is to be returned? So in our case, you return a radius. Maybe let me just put that in brackets. You return radius divided by pi. So assume that is what we want. Is it radius divided by pi? Area is equals to pi multiplied by radius again. Okay, let me just correct that. So it's pi multiplied by radius squared. So which will be pi multiplied by the radius squared. Okay, so assume that is what you have. So in our case, whenever you call out this function, you always expect the output to be pi multiplied by radius squared in our case. So if you changed, if you changed your variable, assume you changed your dimensions, or even maybe your function. In our case here, assume we want to have a function that has a radius of 5, a radius of 7, and the pi changes in our case. Assume pi will be 3. Assume pi is equals to 3. So for this case, if you run this code, or even if you run this, your area is going to be calculated using 3 as the pi, not the original. Not the original. But if we remove this, if we remove that, so the 7 is going to be the radius and pi is going to be used. In this case, our default pi is going to be used in calculating the area. And that is what I meant when I talked about default functions. So for default functions, they are usually predetermined or even preset. And we know in this case, I just replaced this with pass. Pass is used to, it's like a placeholder for future functions. If you need to add any specific function, you want to add any specific code to that part, then you just add. So pass in this case is like used as a placeholder. And then we have parameters with arguments. So in this case, we usually use a star. We usually use a star, this type before the argument, to show that that one is a positional argument, or even to show that what we are representing is a positional argument. And then for keyword arguments, we usually use double stars or even 2 stars. So we are following the same order, or even the same format of functions, but now we are changing the nature of functions. I mean, we are changing the nature of parameters that we are using. Now, and then the last one is a combined one, a combined, or even a function with combined parameters. So we can have the first parameter there being a regular parameter. Then we have an argument or even a positional parameter, positional argument. And then we can also have a default argument. And then we can also have a keyword argument. Now, this is a table that summarizes the three. All the different types of arguments. So this one, or even the args, represent positional arguments. And then kwargs represent keyword arguments. Now, what are the different data types that we can work with, or even that we can use them within these different arguments? So for args, we usually use tuples. And then for kwargs, we can use dictionaries. Then args is used for multiple unnamed values that are not named in this case. And then keyword arguments, they are used for multiple named values. So the values are usually named. For example, if you look at this, you can see we have name, and the name is Musa. And then in this case, the age is 25 or even 23 or even 22. That is the age. So for this case, keyword arguments represent named values. And then args represent unnamed values, like 1, 2, 3, or that is a list or even a tuple. And then args have medium level of flexibility. They have medium level of flexibility, while keyword arguments have high level of flexibility. Like, and you can work around with them. You can change the names to something else. You can also change the age and a lot more. And then args are majorly used for variable length numeric inputs, while keyword arguments are usually used for passing configuration data or optional parameters in this case. So that is the difference between the two. That is the difference between the two. And after now that, I want us to do 7 examples. We are going to do 7 examples. And then after that, we are going to proceed to something else. And these examples, I drew them from the different SDGs, that is the Sustainable Development Goals. And the first one is on partnerships, that is SDG 17 on partnerships. So we are to create a donation function with a default amount. So we just want to create a donation function with a default amount. So in this case, the amount can be any amount of money in this case. But we just donate in money. So the first thing, we donate our function, which is record donation. And this is going to have 2 parameters. That is, we have the first type of parameter, which is a regular parameter, in this case, the donor's name. And then we have the amount, which is now default. The amount in this case is default. Like, you don't have to change this. You don't have to change, it is default, it is preset. So what this does is that it records a donation with default amount. So now we want to print the donor's name and the amount that was donated, the donor's name and the amount. Now for this case, the amount is already preset, so we are not going to have any other amount. Now, let us look at the first one, whereby we only have the donor's name and the amount is not given. The amount has not been given. So for this specific case, the amount has not been given. So what it's going to do is that it's going to pick, or even it's going to output the default amount. So Alice is going to be shown as having contributed 100 shillings or even $100 towards partnerships in that case. So, and then the second one, we have Bob, who contributed 500. So in this case, we've replaced the default amount with 500 in that case. So the output of the second one would be 500. The output of the first donation would be 100. So let us run that. And as you can see, we have Alice donated $100 and then Bob donated $500. So that is it. So we have a regular parameter, and then we have a default parameter. And I hope we are all together in that. Okay. So as you can see in this case, we have the function itself. We have the function name. We have the function name. What is the function supposed to print? What is the function? The function accepts only two parameters, the donor's name and the amount. So what is it supposed to print? It's supposed to print the donor's name and the amount of money that was donated. And then in that case, the return, the output should be now the amount. What is the amount of money that was donated? So for this specific case here, I used print and return at the same time. I used print and return at the same time. So this return will only output the value for the last one. In this case, the last call, which is now record donation, Bob having contributed $500. So if I do away with this, let me just do away with that and see what is going to happen. So you can see after I do away with that, we only have two values. So like I said during our previous session, I said we can use print or we can either use return. So we can use print alone or we can use return. Now let me replace this with return. Let me replace that with return and then paste that. So return, after replacing that with return, you can see what we are having as the output. Only the first output. The output of the first the first variable. I mean the first call in that case, which was not the first but the last. Sorry for that. The output for the last. So if you use return in this case, then it's going to output the last. If we replace this with print, then it's going to output. Sorry, we have something. We have an error. Yeah, if we use print, then you can see we have all the outputs for all the calls in this case. And then once we replace our return, or even we use our return, in this case, return amount, then you can see what we have. We have the output for the print statement and the output for the return statement. So return will always output the value for the last call, which is this. Okay. Now, the second example was on zero anger, that is SDG2. And in this case, we are going to use arguments. We are going to use arguments. We are going to use arguments, which is positional arguments. And for that case, we've said that we can use tuples. We can use tuples, the values that are unnamed. So for this specific part, just a minute. Okay, so we are supposed to calculate the total yield from any number of farms. This is open-ended. These questions are open-ended so that we can be able to work around with them. So we calculate the total the total yield from any number of farms, and we are supposed to use args in this case, that is positional arguments. And our focus there is on SDG2, that is zero anger. So the first thing, we define our function, and our function is going to accept, in this case, it is going to accept any yields. That is, it can be a tuple. It's going to accept any yield. So we are going to calculate the total yield from any number of farms. So the number of farms might be 2, it might be 3, it might be 4. So we are not restricted in this case, but the values are unnamed. So we define our variables. So the total is equals to the sum of yield. We add the values. We add the values. And then the average is equals to the total divided by the length. How many values do we have here? If we have a list, for example, assume we have a list. We have a list. We have farm number 1, we have farm number 2, we have farm number 3, we have farm number 4. Assume these are farms. So in this case, it's going to count the length. How many values do we have here? The length. If there are 4 values, then the average would be the total divided by the length of the yields. If yields, that is, if yields, otherwise 0. We return, otherwise we are going to accord that to 0. Okay, so for this specific function, we are going to return the total, that is the total yield and the average, the two. We are going to return the total yield and the average. So that is our function, having an argument. That is a positional argument. And then we now call out this. Total and the average is equals to total crop yields. And this is our parameter, or even our args, 120, 150, 95, 180. So if we count this, there are 4 values. So that is our length. And then our sum would be the total of this, the addition of this. We add 120 plus 150 plus 95 plus 180. And then our average is going to be now the total divided by the average. So let us find that. Let us run that and see what we are going to have. And you can see the total is 545 tons. And then average is equals to 136.2 tons. Now, let me repeat about this. So if yields, if there are values associated with the yields, or even if we have a parameter within this region, or even within the input, then that parameter, or even the values, are now going to be used in calculating the total and the average. Otherwise, if there are no values, then the average would be 0. The average would be 0 because there are no values. That is what we mean by this. So if there are yields, then find the average. Otherwise, 0. Otherwise, 0. Or even otherwise, the average would be 0. And you can see that. So in that case, we've used an arg. Let us proceed to using keyword arguments. Let us proceed to using keyword arguments. And as we said, keyword arguments are used for multiple named values. And we can use them for dictionaries in that case. Keyword, that is why they are called keyword arguments. Okay, so we proceed to another SDG, which is SDG 4 on quality education. And we are supposed to generate reports with flexible parameters. We just generate reports with flexible parameters. That is, the parameters should be flexible. And in this case, when you talk about parameters, we are speaking about the inputs. So in this case, the first thing, we define our function, which is generate reports. And this one is going to accept any named values, or even any number of values, as long as they're named values in this case. So we generate a report with flexible parameters. And in this case, we are going to print. This is what is going to be our output. Now, this one should not bother you. This is just, it is going to be the headline. Let me call it the headline in that case, just the headline for what we are going to be having as our output. Okay, this is what I was talking about. It's going to be our headline. So education report, and then below it, we have our education report. Now, so for key and value, now we have what we call key value pairs. Key value pairs. Now the key represents the name of the value. For example, when you talk about learners are known by their names. So in that case, the key would be the name, and then the value would be the name itself. So the key is name, and then under name, you can now input the names of the learners, either Musa, either Juma, either Sakawa, and a lot more. So in this case, when you talk about keys and values, we are majorly speaking about the items that make up a dictionary in this case. I know you remember this when we're talking about dictionaries. Dictionaries, sometimes they are created using keys and the values. So for key and value in the report data, this is it. We want the items, we want both of them. That is it. So we want all the items. And when you talk about the items, we are speaking about this. We are speaking about this. The items, that is the name and the age. If that is what we were to deal with. the name and the age. Okay. And then, so we print the key and the value. So in this case, the key would be now the name of the learner and the value. Now, for example, so we have our report here, and the report contains these keys. So school is a key, students, that is a key, teachers, that is a key, and pass rate, that is a key. And then these ones are now the values. These ones are now the values. They are now the values. And then everything here, a combination of the values and the keys is what we refer to as the items. Is what we refer to as the items. So this is what we have. And the output should contain the key and the value. So in this case, you can see we have school being Central High, students being 500, teachers being 25, and pass rate being 92%. So we've output the key and the value. Otherwise, if we only wanted the values, then we would wrap this. I mean, let me just replace this with the key. If I wanted the key, then I would replace that with the key. Like that, and run it. And after running that, you can see what we have are the keys alone. The keys alone. The school, the students, the teachers, and the pass rate. Those are the keys. If I wanted the values, these are now the values. If I wanted the values, then I would just replace this with the values. I would replace that with the values. And you can see what we have. We have an error generate report. Just a minute. Value. Yeah, not values, but value. So you can see after replacing that with value, we now have the values. Those are now the descriptions. That is, for school, what is the name of the school? Central High. How many students are there? 500. So those are now the values. The values. If I wanted everything, I can replace that with items. We still have an error. Just a minute. Now, if we replace that with the initial values, which was the key and the item, then it's going to output everything. That is the keys against their values. And that is what we have. So that is what I was talking about. So for this one, we have the keys and the values. We call them key value pairs. So for keyword arguments, they usually have named values. That is, the values have their names against them. And that is the difference. That is the main difference. Now, we can proceed to the next SDG, which is 1, no poverty. And for this case, we are supposed to find the sum of expenses with the default categories. And for this one, we are just supposed to use default categories. So again, we define our function, and this one is going to accept the first default category and maybe an argument. That is a positional argument. A positional argument. A positional argument might be a list, any number of values. So we assume we want to find the sum of expenses. That is what we want. So we have to find the total. So the total will be the sum of what? The sum of the amounts. So we add the amounts. Remember, these are actually functions that are used, or even they are used in Python to aggregate data. You can use you can use sum. You can also use a lot more other functions. So we have sum of amount in that case. And then what should be the output? So we print the category in that case and its total. We print the category and the total in dollars. And then we can also use this. This can be optional. We can return the total amount of money. And I said that return, whenever you use return, then return will always give the total, or even it will give the output of the last call that you made. So assume we have these 3 expenses that we want to track. That is food for these specific amounts, 50, 30, and 25. And then we also want to track the total amount of money spent on utilities. That is 2 utilities, 150. and then we want to now find the total. So what will be the total? Now remember, in this case, we've used a default category, which is general. And here we do not have that default category. It's not there. It's only food and utilities. So what we are going to have is that we are going to have the totals for food and utilities. And then for the general category, it's going to be 0. It's going to be 0. Why is it going to be 0? Because there were no inputs for the general category. There were no inputs for the general category. Okay, so we run that, and you can see we have food 105, utilities 150, and general 0. What about if we changed this? Track expenses, and then we maybe added something. We added 40, 50, 67, and run that. 40, 50, and 67. Now, if you run this, you can see what we are having here. So Python is regarding the first value as the category. And then the second and the third values, these are being considered as the amounts. So you have to input the category, which is now general. You have to input the category, which is general. So we can add the category here, general. You can input the category there and run it. And you can see now for the general category, we have a total of $157 that were used for food, or I mean for general expenditure. So that is it. So in this case, we've used positional arguments. We've also used a default argument. And I believe all of us are good. I believe we are now good. So the next one is on SDG 13, that is climate action. And we are supposed to collect environmental data with flexible parameters. So in this case, we need flexible parameters, parameters that change. So when you hear of flexible parameters, we need a positional argument in that case, something that is flexible, and we can also use keyword arguments in that case. You can also use keyword arguments, and you'll be able to change the keywords. That is now the keys. That is, if you need to make changes to the keys, you can add new keys, and then you can also change the values. Okay, so this is our function that requires 3 functions. That is the location, the measurements, and the metadata. And we have the average measurement. So the average measurement is equals to the sum of measurements over the length of measurements. How many measurements are there? So if there are measurements, otherwise if there are no measurements, then the average measurement will be 0. And then in this case, we need to print the location. We also need to print the average measurement. And then for the key and the value, that is for each key and value in metadata, that is now our metadata here, because it is a keyword argument. That means that it has a key and a value. So for each key and value in the metadata, we need to return the key and the value. And then now we call out using this. This is now the record environmental data, and the name of the location is Forest A. Then these are now the measurements, positional arguments. And then we have the metadata. Metadata now has 2 keys. We have the unit and the date. The unit and the date. And then the values are Celsius and the date, in this case, this one. So let us see what is going to be our output. We run that, and you can see the output contains the location, which we talked about, Forest A, and then the average, which is 23.80, the unit, which is Celsius, and the date, which is 2024-01-15. So that is it. That is it. So I believe all of us are good until there. So I will not go through example 6 and example 7. They are all the same. They are all the same. They involve use of default values, kwargs, and args. So I will not go through that. So allow me to go through the next one, which is PEP, PEP principles. PEP principles. Now, PEP is a short form for Python Enhancement Proposal. That is Python Enhancement Proposal 8. that defines the style and the different guidelines that are used in writing Python codes. And this one ensures that the code is readable, it is consistent, and also professional. And where do we use this? We use it in everything. When we are writing every code in Python, we use this concept. Otherwise, if you don't follow these principles, then your codes are going to be returning errors. You're going to be getting errors, either indentation error and a lot more errors. So they are very, very important. They are used in writing codes in Python projects, open source softwares, and also industry standards. So these are the guidelines. These are the guidelines. I just summarized that in a single table. So we have the line length. The line length is always a maximum of 79 characters. So always when you're writing codes, ensure to keep lines short. Then indentation, that is indentation, use at least 4 spaces. That is, if you are using your space bar, ensure that you use 4 spaces for indentation. And if you choose to use spaces, then be consistent, use spaces. If you choose to use tabs, then use tabs in that case. Then we have naming. Most of the times when we are naming functions, just like I spoke about here, when you're naming functions like this one, this is a function name. When we are naming functions, we use lowercase with underscores. We use lowercase with underscores, and this is an example. And then when you're giving classes, when you're naming classes, we use Pascal case. And then for constants, a constant, when you're giving a constant, something that never changes, you use uppercase with underscores, uppercase with underscores. And then for spacing, we use 2 blank lines between functions. And this is actually used to organize the code. It is usually used to organize the code. If you look at the different codes that I have here, I have a space. I have a space between the different functions. You can see we have space between the functions. And then you also need to space if you're having arithmetic signs like plus, like minus, multiplication, division, you also need to ensure that there's a space before the sign and after the sign. And then for any inputs, if you're inputting any program, then all imports must be done at the top of the file. They must be done at the top of the file. And you do that, or even you write the import in lowercase. And then for comments, we use this sign hash, or we can also use, we can also add the comments using these triple quotation marks. You can also use triple quotation marks. Okay, so this is an example of proper function naming. So if you look at the first one, there is an explanation to what we are doing in that case. And then there is also correct indent in that case. The C and the R are vertically aligned. The C and the R are vertically aligned. And apart from that, you can also see the variable name. The function name is well written using lowercase and underscores. For the second one, we've started with a capital letter, and then the words have been jammed together. They've been jammed together. So that is wrong. That is wrong. Same to the third one. Is also wrong. Proper variable naming of variables. If you look at the first one, everything is okay. Everything is okay. Monthly income is equals to this. Poverty threshold is equals to this. Now, if you look at the second one, we've used initials. My can represent something. It might mean something else. PT might represent something else, platinum. EFA, it might mean something else. So for someone else who will be using maybe your codes in future, it will be a great challenge for them going through your code, and it will be a challenge for them to be able to understand your code. So you have to ensure that you name your variables properly. If you're looking for the poverty rates, then write in full poverty rates. If you're looking for maybe the average income, write average income, don't write initials. Then the third one is proper spacing and formatting. So if you also look at this, we have proper spacing and formatting. proper spacing and formatting. So your words must be properly spaced. So the first one is correctly done. You can see we have the variable, the function name, we have the variable itself, and then we have the return. So everything is well spaced. Now, what about the second one? What about the second one? If you look at the second one is also correct. The second one is also correct. But now the third one, there is a lot of jamming. Between the inputs, the two parameters, there should be a space. That is where we have the comma, we should have a space. If there is no space, then that would be incorrect spacing. So there should be a space there. Same to this, where we have this specific sign, that is the multiplication sign. There should be a space after and below, like in this. Otherwise, it will be wrong. Now, between these two functions, these are two different functions, you should ensure to leave at least two lines of code, at least two lines of code, of empty cells. Let me not call them empty cells, but at least two lines. So you ensure that you click at least twice, your enter icon, your enter tab at least twice to ensure readability of your code. And then we have proper comments, ensure you comment out your code. We can use what we call block comments, and we can also use inline comments. So this is an example of a block comment. That is a block comment. A comment that begins at the same point where your function begins. That is, it begins on the same point where your def begins. That is a block comment. And then we have inline comments. Inline comments, they are those comments that are usually done at the end of lines. So for example, assume I wanted to explain what this variable does. What this function does. So I will come here where I have this specific colon, then I would add my comment there. So that is an inline comment, and all of them are usually nice. The only thing that you're not supposed to do is jam in your code with a lot of comments, like trying to explain every sentence. That would be irrelevant, and it would also make your codes to be crowded. Then we have proper constants. For all the constants, always ensure that you define them using capital letters with underscores. That is uppercase, just like what we've done here. These are actually constants. They never change. So for the entire code, these constants will never change. Now, this one is wrong. This one is wrong because in this case, we've defined them the same way we define a function or even a variable, which is very, very wrong. And then for import, just like I said, if you want to import anything, for example, you want to import maybe OS or even maybe system, then that should be done at the beginning of your code, not in the middle here. You do it at the beginning of your code. So import OS, import system, and then from there you now proceed. Where are we importing it from? We are importing this from datetime. We are importing that from datetime. And then for the second one, which is this, we are importing it from collections. We are importing that from collections. So you have to mention the specific program where you are importing a space, because you might not need an entire program. You might not need an entire program or even an entire program. You might just need a part of a program to run your code. So in this case, for example, OS is the main program. And then from OS, we are importing datetime. Maybe we are importing that, or even let me say datetime is my main OS, my main program. And then from that, we are importing this specific mini program that is going to maybe help us in running our code. So that is it. So we import them firsthand at the beginning of our codes. And that is what we do. For this one, this is wrong. That is wrong. Because you've already defined your function, and then within your function, you are now looping the importation. It's like this importation is part of the function. That is what this means. The importation process is part of the function, which is wrong, which is very, very wrong. So that is it. And then, So this is just an example. This is just an example. Complete PEP8 compliant program on SDG 2, that is zero hunger. And we are supposed to write a complete program following all the PEP8 guidelines. So the first thing we are going to import statistics. And then now from typing, we are going to import the list and dict. We are going to import those two programs that are going to help us in running our codes. And we are importing that from statistics. This is the main program. And then we now define our constants. Minimum yield is equals to 100, optional yield is equals to this, and maximum yield is equals to this. And then from there now we define our function. You can see that the function name should always be in line. Should always be in line with the return statement. They should always be in line with the return statement. And then the others should be indent. That is, they should be intended. Same to this. This is a second function. You can see there is some space to ensure there is readability of the code. And then our third function, and the code, the function continues on and on. So that is it. That is it. So PEP is majorly to ensure that our code is easier to read. It is to also ensure that it is clear and concise. In that case, clear and concise, that such that whenever people use your codes, maybe in future, they'll be able to understand what you are trying to do, or even what you are doing for that specific part of maybe the project. Because sometimes you might be collaborating with peers on GitHub, on maybe assume you're creating a mobile application, or even maybe you're creating a software, or maybe anything to do with technology. And you are collaborating with peers on GitHub, and everyone is doing maybe a specific part of the project. So for you to be able to continue your peers' part of the project, you have to understand what they were doing for you to be able to continue that. So you have to ensure that your codes are clearly done. They are clearly, there is clear comments. And apart from that, you also ensure that it is readable. Okay, so we are done with that. And I believe all of us are good until there. Can you confirm? Are we all good until there? Anyone? Okay, thank you. Thank you for the confirmation. So the next one is on object-oriented programming. And I believe this is where most of us had challenges, object-oriented programming. I think someone's hand is up. Okay. Whose hand is up? Kindly, for the panelists, you can help me maybe get to see those guys.
Continue. I don't,
okay.
There's nobody, continue.
Okay, thank you. Yeah. Now, on object-oriented programming, this is, I can say that this is really vast, or even it is really wide. So I'm not sure whether I'm going to be able to go through all of it, but I would try my best to just cover what is most important. So object-oriented programming is a programming paradigm that organizes code into objects and classes. So objects are usually organized into objects. That is, code is usually organized into objects and classes. And when you talk about an object is an instance of a class. There's an instance of a class, or even an example of a class. When you talk about object, it is like an example, or even a sub-branch of a class. Now, let me give an example using, let me use maybe a tree. Let me use a tree. So a tree is now our class. And then for that specific tree, we might have its branches, or even the leaves. The leaves are now the objects. They are part of that class, or even they are sub-branches of our main class, which is tree. Now, when you talk about species, we have different species of organisms. So species can be our class, and then objects are now the animals that fall under different species. For example, mammals, carnivores. We also have maybe rodents and a lot more. So in this case, a class is the blueprint that is used in creating objects. It is a blueprint that we use in creating objects. It is like the mother. Let me call it the mother, or even the parent print that we use when we want to create now children prints. I'm not sure whether that makes sense, but let me just continue. So it contains data attributes. An object contains data, which is also called attributes, and functions. Functions are called methods. So an object will contain two values. That is, the first one is attributes. The first one is attributes, and the second one is methods. The second one is methods. So we usually have attributes and methods. So methods are now the functions, attributes are now, it is now the data. And all these are part of the class. So where do we use this? We use this in large-scale applications, large-scale creation of frameworks, and also professional software development. Why is it important? It helps us to organize complex code, organizing complex code, promoting code reuse, and also making programs more maintainable. This is a summary. This is just a summary. But before I can take you through this summary, let me just take you through this table. Let me just take you through this table. For the first three, we have the class. I've said that class is a blueprint that we use in creating objects. For example, if we want to classify organisms, then we are going to classify them based on their species. Just like I said, every organism belongs to a different species. So you'll have species being now the parent, let me call it the parent function, or even the parent function. And then within the parent function, we are going to have the object, which are now the children functions. That means that they are dependent on the class. They are dependent on the mother function. So class is the blueprint, then the object is now the instance. And just like I said, object is made up of two things. That is the attribute and the method. The attribute represents the data or the property of an object. The data or the property of an object. And then the method represents the function inside a class. The function inside a class. Now, before I take you through this, let me just elaborate on that. Let me just elaborate on that. So for example, in this case, we have our class student. We have our class, which is student. So that is our class. That is our class. And then the next thing, we've talked about attributes being the data or the property, and the method being the function. So we have the method being the function. So all the functions within our class are now, all the methods within, all the functions within our class are now the methods in our case. These are now the function. They are now the methods, sorry. These are the methods. So this one and these ones, they are the methods. And then these are our main class. Okay. And then now within every function, you will have data or even the properties. You will have data or even the properties of that object. For example, if you're discussing, if you're talking about a student, then what is the color of that student's uniform? What is the color of that student? Is the student maybe chocolate in color? Is the student black in color? What is the color? In that case, those are now the properties of an object. Now, apart from that, we are also going to discuss about inheritance, encapsulation, and polymorphism, the three. Now, inheritance, in this case, it is a phenomenon whereby the child class inherits from parent. The child class inherits from parent. And I think I'm going to explain about that further from this specific table. And then as encapsulation means hiding internal details. And then polymorphism means same method, but now different behavior. Okay, let us now dig deep into this. So what is inheritance? Let me begin with the inheritance. This is a mechanism where a new class derives attributes and methods from an existing class. So a new class derives attributes, these are now the characteristics, and methods from an existing class. Okay, so it allows a class, which is also called a child or even a subclass, to acquire the properties and methods of another class, which is called the parent or the superclass. This is an example. This is just an example. So we have the class. In this case, the class is animal. Let me change that to code. So we have the class, which is animal, and then we are defining this specific function. We are defining that function. You can see the indent in that case, and then we return some sound. What is supposed to be returned from that specific function is some sound. Now we have the child class, which inherits from the animal. So this is a subclass of this one, or even it inherits characteristics from this. So we have class, and in this case, we are speaking about this specific animal, which is dog. So this one depends on this class, which was animal. So it depends on that class, which was animal. What makes us know that this is a subclass of this specific statement here? We are defining another class, but now using an old class. So this is the mother class, and this is the child class. So we define now speak, self, and then return wolf. And then the third class is cat, which is also a child class. But now it is also dependent on our initial class, which was animal. And then we define our function and then our return statement. So for now, maybe this is not going to make a lot of sense, but as we go through the examples, it's going to maybe make more sense. So for this case, we output. Let me just comment out this. But before that, so the dog and cat classes inherit from the mother class, which was the animal. That is what we've just said. They inherit. So that is what we call inheritance. That is what we call inheritance. What is the purpose or the goal of inheritance? To promote code reusability. You can imagine having to write this specific code here each and every time. Whenever you are defining, whenever you are coming up with a class of a different animal, you create this each and every time, or even you write this above that class each and every time. It would be very, very hectic. Assuming you have 100 animals that you want to know, maybe you want to know some specific attributes or even some specific characteristics from them. Having to write this 100 times will be very, very hectic. So with this, you can be able to list all the animals below this main class. So you are having your animal as dog, you are having your animal as cat, your animal as maybe a zebra, a monkey, and a lot more. So it promotes code reusability and also establishes hierarchical relationships. It enables us to have a hierarchy. We now know that this is our mother code, and then, or even our mother class, and then all the others are dependent on that specific class. And then our real world analogy is that, or even in order for us to be able to understand that better, we think of a child inheriting traits and behaviors from parents. So we inherit what we acquired from our parents. If your parent was maybe short, then chances are that you're going to also be short. If your parent was maybe tall, then maybe tall and slim, then chances are that you're also going to be tall and slim. So we inherit what we acquired from parents. Otherwise, if you don't, then something else might end up popping up. Guys running to do DNA and a lot more. Then what are the benefits of inheritance? Number one, reusability. The code is usually organized, and then we usually have extensibility. So this one mostly focuses on reusing of code and class hierarchy. Now, before I can take you through the others, let me just take you through examples. Let me just take you through some examples. Let me just take you through some examples. They are down here. Let me see. I'm not sure that these ones depend. Anyway, I didn't differentiate these values. Anyway, I will just take you through that in a while. Let me just take you through everything so that we don't waste a lot of time. So the second one is encapsulation. Encapsulation. And encapsulation builds, is the bundling of data and methods into a single unit, that is a single class, restricting direct access to internal details. So this one restricts internal access to internal details. Okay. So for example, we've said that encapsulation is the hiding of internal details of an object and restricting direct access to its data. And it's always about controlling how data is modified or viewed. So you restrict access to some specific data. You restrict access to some specific data. Now, for example, in this case, we have our class, which is bank account, our class bank account, and then we define our function in this case. So for us, we use init. And I know when you're going through these specific functions, you are told that init is one of the main keywords that we use when, that is in Python, one of the main keywords that we use in Python when defining functions or when working around with problems related to Python. So this one is majorly used. So we define that, and then we have two parameters. We have self and balance. And then for self, balance will be equal to balance. So this is a private variable. It is a private variable. And then we define another function, which is now deposit. Deposit is going to have amount. So for self, balance is going to increase. We are going to pick the amount plus the balance for that case. So plus equal to, this one means you add. Like every time you have a specific balance, you add that to amount. You add that to amount. So if the balance in our first function was 200 and the amount in the second function was 300, so in that case, our total balance would be 200 plus 300. That is what we mean by this specific code. So balance, then plus equal to amount. That means you pick amount plus balance. And then the last one, get balance, that is a function that now gets the total balance for self, and then we return self balance. We return this. So this one is actually giving us the total amount of money. What is the total balance? And the total balance would be the balance in the first function plus the amount in the second function. And that is what we are going to have. So for example, if we have an account whose balance is 100 for the first one, and then for the deposit amount was 50, what would be the total balance? What would be the total balance in the bank? It would be 100 plus 50, which would give us 50. So now we print account, get balance. We print account plus get balance. This one, account plus get balance. This one. Remember, this was the last function. And what we get here should be 150. So just like I said, this one is a private variable. It's a private variable in our case. It can't be accessed directly from outside the class. We can't access that out from outside the class. For example, if I run this, let me first of all remove the intent and run that, so that you see what we're talking about. So you can see self-balance, in this case, expected an indented block after function definition on line 2. So this one, it was a private variable. That means that you can't access it from outside this class. From outside this class means that if class and this one are on the same level, then all of them are going to be considered as different classes. They're going to be considered as different entities. So if now I intend that, and run it, you can see we have 150. The output is 150. So for this specific value, we've used encapsulation. Like we are hiding this within our class. We are hiding that within our class, such that if we want to know the balance, we have to pass through the class. We have to pass through the class in our case. And I hope that makes sense. So that is it. That is it about encapsulation. So encapsulation is used to protect data and ensure that we have controlled access through defined interfaces. And in real world analogy, you can imagine that, or even you can think of that as a capsule of medicine, whereby you store medicine within a capsule and no one can access it directly. And this one majorly focuses on data security and hiding internal details. So if maybe you had a specific part of a code that you didn't want someone to access externally, then you use encapsulation. And how will you be able to do that? You just ensure that that specific part of the code is within a subclass, or even, within a class, such that if anyone wants to maybe get access to that specific code, they will have to go through the class. Then the other one is polymorphism. Polymorphism is the ability of different classes to respond to the same method name in different ways. Polymorphism. Different classes responding to the same method name in different ways. And this one enables flexibility and also interchangeability between objects. Apart from that, this one also focuses on method overriding and different behaviors under a common interface. So it focuses on method overriding, that is method overriding other methods, and also different behaviors under a common interface. Okay, an example, let me give you an example. So before we move on to different other examples. So we have our class here. And then we are defining this specific function. And then what we are supposed to return is chap for that specific. If the animal makes sound, then we return chap. Then the second one is class dog, and then define make sound. In this case, return back. We return back. And then the third one, in this case, so we only have two functions, the two of them. And for this case, for animal in bird or dog, print animal and make sound. So all these, this criteria is going to output, or even it's going to be dependent on this specific code. It's going to be dependent on all that. It is going to be dependent on that, the two classes. So we are having different classes using the same method. These are two classes, but all of them will be using this specific method to give us an output. So they use the same method name, but behave differently depending on the object calling it. So in this case, what is the object calling it? In this case, we are interested in a bird or a dog. So a bird would now be represented by the first function, and then a dog would now, the output would come from the second function. But these are two different functions, but they all behave the same. They all depend on the same method, which is this, for them to be able to give us an output. So both classes define the method make sound. They all define the method make sound. So you can see that they all behave the same. That is what I was talking about. They behave the same. Okay. So if we run that, then for a bird, it's going to chap, and for a dog, it's going to bark. So for animal in bird, this is the first class. For animal in bird, which is the first class, or dog in the second class, print animal and make sound. So we only print, in that case, the sound that is made by that specific animal, which is chap or barking. So for this case, that is the difference between polymorphism and encapsulation, and also inheritance. So, and I believe that is a bit clear. Let us do some maybe around 3 to 4 examples, and then we are going to proceed to the next. So we have a simple, I mean, we in this case, we have a simple student class, and majorly we are going to be concentrating on SDG 4, that is quality education, and we are to create a class to represent a student, just a class to represent a student. So in this case, we are to represent a student in the education system. So the class would be student, then a colon, and then we define the parameters for that specific function. We should have the name, the student ID, and the grade. The name, student ID, and the grade. And in this case, if you look at this, these are open-ended parameters. They are not key value pairs. Okay, so we initialize the student's attributes. What are the attributes? I talked about the attributes. So the name of the student is equals to name. The student ID is equals to the student ID in this case. We are defining them. The student ID is equals to this ID, and then the grade is equals to this grade. Just like we used to do them in SQL, we are just defining or even initializing these attributes. And then the second function, we are now defining the info to be displayed. What is going to be displayed? We've already defined the self, the first part of the self. That is now concerning the student. We've defined everything. So concerning the self, we are to print the name, the ID, and the grade. And then we call out using these two values. The first one is a student 1, who is Alice. The ID is S01, and the grade is A. And then the second one is Bob, ID 2, with a grade of B. So let us see what is going to be our output. So we want to get the output for student 1 for the display information. This is what we want. So anytime we call out the display information, this is what is going to be our output. That is what is going to be our output. And anytime we call, that is it. That is what is going to be our output. We don't have any other function. So we have two students, 1 and 2. So we print the value, the display information for the first student and the display information for the second student. And let us run that and see what is going to happen. So you can see we have Alice with ID this and grade of A. And then we have Bob, ID 2 and grade B. So for this one, what we are doing is that we are just defining, we are just inputting the values of the student. In this case, whenever you have this specific type of functions, let me call them functions. I mean, when you're having a class, then this is always the first part. You can always have that as the first part, self, whereby you key in the attributes of what do you want to have. The attributes would now be now this: the name, the student ID, and the grade. But now you have to initialize them. That is always the first thing. You have to initialize them. And then the second thing, you can now come up with an output. What do you want to be the output? You can now come up with a second function. Now, the second one is to create a class to manage bank accounts. We want to create a class that is going to manage bank accounts. That is to solve SDG 1, a class to manage bank accounts. And in that case, we need to solve the problem of poverty. So just like I said, we come up with our class bank account 1, and then that represents the bank account. And then now we come up with a function. The function contains the first part, which is self, and now the attributes. We have the account holder, who is the account holder, and what is the initial balance. Those are now the attributes. So we initialize the account. That is the first thing, just like I said, initialize the account. So the first function should initialize that account. So the self account holder is equals to account holder, this one, It is equals to that. And then the self balance would be equal to the initial balance, which is 0. Now, the second function is this. So the second function in this case has the self, like it has the details from the first function, but now we've added amount. So we are adding money to the account. So what this function is going to do, it is going to have all the values from the first function. That is the account holder and the initial balance. It is going to have those two values. And then we are going to add another thing. The self balance is now going to be generated by picking the initial balance plus the amount of money deposited. How much money was deposited? This is the amount we add. So plus equal to that represents add. So we have the self balance, which is this, the output of the first variable. Let me call it the output of the first function, which was self balance. And then we add that to the amount. So if the initial balance was 0 and this person deposited $20,000, then the running balance would be 20,000 plus 0, which would be 20,000. So that is what the second function does. So now we print the amount. We want to get the amount, this specific value here. And this amount would be now, it would be now the amount that was deposited. And then we also want to know the new balance. What is the new balance? The new balance is our running balance, such that if someone deposits 20,000, the next time they deposit 100,000, then all that money is going to be accumulated together, or even it is going to be added together. And our new balance would be now the sum of all those amounts. So the output of this would be the amount that was deposited and the balance, the remaining balance after the deposit. And then the third one is to withdraw. We are defining another function that withdraws money. I mean, that now is about withdrawing money from the bank. Assume we want to withdraw money from the bank. So in this case, we are going to have self. These are the details from the first, or even it will be now the values from the first function, and then amount of money withdrawn. How much money was withdrawn from the account? So in this case, if amount is less than or equal to the self balance, so if amount of money withdrawn, that is, if the amount of money withdrawn from the bank is less than or equal to the self balance, then pick the balance, which is now the running balance, minus that amount. Otherwise, if the amount of money withdrawn is bigger, then cancel it, because you can't withdraw a high amount of money than what you have in your bank. You can imagine having 100,000 in your bank, and then you want to withdraw $1 million. It is impossible. So you only withdraw if the amount of money is the same. Is the same or less than. Otherwise, so in this case, otherwise, print insufficient funds. Otherwise, print that. So if the amount is less than or equal to, then print amount and the self balance. That is the running balance after now withdrawing. And then the last one is to check balance. We need to check the balance. What is the remaining balance? In that case, what is the remaining balance? So we need to check the remaining balance after withdrawal. And that is it. And I believe that was, I think you guys have understood on that. So for this specific part, our account name is John, and the initial balance is 100. John, initial balance is 100. And then this person deposited 500. So after depositing 500, the running balance is now 100 plus 500, which gives us $1,500. And then this person withdrew 200. After withdrawing 200, the running balance would be now 100 plus 500, which is 1,500. We minus 200, which would be 1,300. So if we check the final balance would be $1,300. So let us run that and see. So you can see we are having deposited amount is 500. The new balance is 1,500. This person withdrew 200. So the new balance is 1,300. So the remaining balance in the bank is 1,300. It is 1300. So what we've just designed there is something that you can use. Actually, this is something that you can use in, assuming you're working in a banking institution and you want to maybe track how money comes in and how money goes out of the bank. You just design something like this using Python and install some maybe firewalls, and everything is going to work. So this is something that is used majorly in the bank to track changes. That is to track how money was withdrawn and how money was deposited. Then the third one is on solar panel class, in this case. So this is on SDG 7 on clean energy, SDG 7 on clean energy. And we want to create a class to track solar panel performance. We want to know the performance of a solar panel. Very, very simple. We want to know the performance of a solar panel. So the first thing, we define our class. It is a solar panel. So what are the attributes of that solar panel? Number one, we need the solar ID, that is the panel ID, and the capacity in watts. What is the capacity, the total capacity? How much energy can it hold? Is it 20,000 watts? Is it 2 million watts? What is the capacity in that case? So we initialize. So the panel ID is equals to the panel ID, this one. Capacity in watts is equals to the capacity in watts. And the self-daily production is equals to 0. So this is another value that has been added. There's another value that has been added. Self-daily production is equals to 0. That is now the original value, which is equals to 0. So you can add this. This is like a default value. It is equals to 0. And then now we need to calculate the daily production. What is the daily production? So for the daily production, we are going to check the sunlight hours, or even the number of hours that this solar panel was exposed to sunlight. So the self-daily production is equals to self-capacity in watts, that is now the capacity in watts, times the sunlight hours over 1,000. So this one is just trying to determine how much energy was produced on a day. That is on a single day. And then what we return is the daily production. What we return is the daily production. And then the third one is now gauging the efficiency of that solar panel. So if the daily production is less than 2.5, is greater than 2.5, then we say that it is excellent. Otherwise, we say it is. Otherwise, if it is greater than 2, then we say it is good. That is from 2 to 2.5, it is good. 2.5 and above, it is excellent. Otherwise, less than 2, then it needs maintenance. If the performance or even the daily production of energy is below 2 watts, then that one needs maintenance. And then we check. So for the first variable, it is a solar panel whose ID is 1,000 and capacity in watts is 350. So production, in our case here, would be 8 hours. 8 hours of energy. It was exposed to 8 hours of energy. So we need to know what is the daily production and what is the efficiency. What is the efficiency? That is what we want to know. The production and what is the efficiency. And let us run that. Now, some of us might be asking, what are these? Now, this is 2 decimal places. So anytime you see 0.2f, that represents 2 decimal places. So I need my value to have 2 decimal places. So the daily production is 2.8, and that is excellent. It is excellent. So again, that one is helping us to solve or even to track the performance of solar panels. The performance of solar panels. So with this kind of data, you can be able to solve various maybe challenges affecting us on a global level. Okay. Let me do the last 2. I'm going to do 2 more, and then maybe we can proceed to the next. We can proceed to the next. So we now move to good health, SDG 3. SDG 3. And we are to create a class to manage patient records. We want to create a class to manage patient records. Assuming you work in a health, maybe insurance company, or even you work in a health organization, that is maybe an hospital or even maybe a dispensary, and you're told to create a class or even to create a system that tracks the record or even manages records of patients. What are you going to do? So this is something that maybe it's going to help you maybe navigate through that. So this is a class. The class is patient in our case. And then the first thing we need to represent the values. What are the attributes of the patient? We have the name of the patient, the ID of the patient, and the age. So we define them. And then in this case, we are adding something else, medical history. In this case, it is a list, an empty list, because we don't know whether that patient had a medical history or not. So we leave it empty. If the patient had maybe medical history, then we append it there. We are going to append it there. Okay, then the second function in this case adds the medical records. So for self-medical history, append the record. Append the record. So if a patient comes in and they have a medical record, a patient comes into the hospital and they have a medical record, then we append that to the self-medical history. We append that to the self-medical history. And then what we are going to print there is the record that was brought in. And then for the last one, we need to get the medical history. We need to get the medical history. So for this one, or even we want to display that. So how are we going to display that? We are going to display the name of the patient, the ID of the patient, and the age. And then besides that, we are also going to add the medical history. We are going to add the medical history for our case. So if a patient came in and the name was Sarah, the ID was P01, and she was age 35. And then medical history is that she had a COVID-19 vaccination, and then the checkup was normal. That is the medical record. The record was she had a COVID-19 vaccination, and then the checkup was normal. Then what would be the history in our case? What would be the history? That is what we want to get. So let us run that. You can see the record added here is that vaccination was done for COVID-19. Then the other record that was also added was that the checkup was normal, or even she was normal after checkup. And then this is a medical history for Sarah. This is just additional information. This is just additional information. So in our case here, we didn't print out the name, the patient ID, and the age because we didn't include it here. We didn't include it here. If we included it here in our last print, or even in our last values here, then it would have been output. It would have been output. Okay. So the next one, our next one is on SDG 8, decent work. Decent work. So use inheritance to create different employee types. Use inheritance to create different employee types. So in this case, we want to create different employee types, but we want to use inheritance. We don't want to keep on repeating the title of the employee, or even we don't want to keep on repeating the word employee, because we might have different employees. So you can imagine having 100 employees and you're creating maybe a function, a class about each one of them. It's going to be tiresome. So in this case, we use inheritance. So as I said, this is our mother class, and this is our child class. That is our child class. You can also add another child class below it. So for this one, for the mother class, we've initialized the employee. So for the employee, we must have the name, the employee ID, and the salary. And then here we now display the information. We display the information. What is the name of the employee? What is their employee ID? And what is their salary? We display that. And then for the child class, we are now inputting a new class, which is the manager. And a manager is an employee in this case. Or even this one is dependent on the mother class, manager. So manager class inherits from employee. And then for the manager class, we have their name, their ID, their salary, and their team size. So we've added a new thing here, the team that they manage. And then apart from that, we also do the same. We initialize that specific class. We initialize that. And for our case here, we are going to use, we have the name, we have the employee ID and the salary, and then the team size, that is what we are adding. This is what we are adding. The team size is equals to the specific team size because it's been added on the child class. And then we now display the information. What do we want to be displayed? We want to display the info. We want to display the info. That is, we display this, everything on the self. That is everything on this specific function. And then apart from that, we are going to also print the team size. What was the team size? So if we have an employee whose name was John, ID 01, earning a salary of $3,000, and then the manager was Alice, ID 01, earning a salary of $5,000, managing a team of 10. Then we want to print the employee, in this case, their info. We want to print the employee info and the manager info. And let us see what we are going to have. So for the employee, you can see we have John, E01, earning a salary of $3,000. And then for the manager, we have Alice, ID 01, salary 5,000, team size 10. So in this case, this one, or even the output of the first one was dependent on the parent. It was dependent on the parent class. It was dependent on the parent class in that case. That is why we used employee here in brackets to mean that it's dependent on this. This is a subclass of this. So I believe that is great up to there. So we have more examples. I'm not going to take you through all this because I believe you guys are good up to now. So allow me, if in case anyone has questions, I will come back to this. I'll come back to this. So allow me to take you through the last part for our today's session, and then maybe I can welcome in any questions. So advanced functions. And this is also another part where most of the guys had a lot of challenges. Now, for advanced functions, we are going to be dealing with Lambda and recursion. So Lambda functions are small anonymous functions that are defined with the Lambda keyword. So we use a Lambda keyword. And then a recursion is when a function calls itself to solve a problem by breaking it into smaller subproblems. Like it breaks itself to so many subproblems, like infinity parts of it. Sometimes the problem may take forever to end. Some other times it might end if you put a limit. But for this case, where the recursion comes from the word recurry, So it means that a function calls itself to solve a problem by breaking it into smaller sub-problems. Then Lambda functions, they are usually defined using the Lambda keyword. So where do we use this? Now, most of the times we use Lambda functions with map, filter, and sorted. We know these functions, that is the map, the filter, and sorted, while recursion is used for tree traversal, factorial calculation, and divide and conquer algorithms. As we proceed, I know we are going to, or even I'm going to take you through this. The three, we have tree traversal, factorial calculation, and also divide and conquer algorithms. Now, this is a summary. This is just a summary. So we have map. We have a map function. This applies a function to all the elements. So whenever you have a map before a function, it applies a function to all the elements. So this one returns an iterator. And this is an example of a function. So you can see we have Lambda. So we have Lambda, and then we have what we want to be output, and then we have the input. This is the Lambda function. Then x raised to power 2, x times 2 in this case is the output. What do you want to be output? It is this one, this value here. And then we have our input. So that is it. And then we have filter. The filter function filters elements based on a condition. So this one is used to filter elements based on a condition. And what it returns is also an iterator. And an example is what we have here in our case. So we replace map with filter. Then the last one is sorted. And this one is used in sorting elements. And mostly this one works with lists. It's used in sorting elements. So why is this important? It makes our code concise, while recursion is essential for solving problems that have recursive structure. So recursion is very, very important in solving problems that have recursive structure. So this is our general syntax. This is our general syntax. We have lambda, then followed by the argument, then followed by the expression. Followed by the expression. Okay. So I'll go directly to a few examples. That is back to our SDG 1, no poverty, or even zero poverty. So we are to filter people eligible for assistance using Lambda. We only want to filter those people who are eligible to be assisted using Lambda. And in this case, we have a list of dictionaries. We have different dictionaries. This is the first dictionary, the second one, the third one, and they are all enclosed in a list. That is a list of dictionaries. So we have the name and their income. So we can call that, we say that dictionaries have what we call key value pairs. The key, these are the names and the incomes, while the values are the Alice, Bob, Charlie, and 150, 250, 100. So we want to know among the three people who is eligible for assistance, who needs assistance. So we are going to set a threshold, which is 200. So if someone is way above the poverty threshold, I mean, if someone is below the poverty threshold, if they earn money that is below the poverty threshold, then that means that they are eligible for assistance. Otherwise, if you're earning a lot of money, which is way above the poverty threshold, then you don't need assistance. So for this case, eligible is equals to, we start with this. I'm just going to take you through that. We begin with that, lambda of P. And then P into brackets income, this is our input. This is our input. This is our input. P into brackets income is less than the poverty threshold. Is less than the poverty threshold. And then, now P in this case is just a character. You can also use X, you can also use M for your case, but if you use M here, you also remember to use M here. So we have this, and then we have the income. Now, the income column, we are getting this income column from this list. Remember, this is a list. It is a list of dictionaries. So we are getting the income column from, the income from our list. This one, it's here. So if the income is less than the poverty threshold, then what are we supposed to do? Print eligible for assistance. That is what we are supposed to do. And remember, in this case, we have to also give our expression. What is our expression? Our expression is people. Where are we getting the values from? We are getting the values from this expression, which is people. That is where we add it there. So this is our argument. That is our argument. This is our lambda function, and this is our expression. So if the value is less than the poverty threshold, then we print eligible for assistance. Now, for person ineligible, print, if the person is now eligible, then print what? Print their name. That is now from the people. Print their name and their income. So this is just additional information. This is just additional information. You can stop at this, print eligible for assistance. And that one will actually print eligible for assistance. It will just look for any value here. If one of the values is less than, then it will just print eligible for assistance. Otherwise, if we want to now narrow down to a specific person, we want to know which person, or who was eligible for assistance, then we now check if the person in this specific if the person in the eligible output, in this case, if the person is in that specific list, then we print their name and their income. Okay, so you can see this is the output of the first one, just like I said. So what this will do is that it will look for any value here. If one of the values here is less than 200, then it will print out eligible for assistance. But now this one is more narrowed, or even it is more concise. It gives the name of the person who is eligible for assistance and the amount of money that they are earning. And this one proves that your code is correct. Now, the second one, we want to convert the temperature from Celsius to Fahrenheit. From Celsius to Fahrenheit using Lambda. That is on climate action. We want to know maybe which regions had extreme levels of temperature and which ones had low levels of temperature. So for this specific one, we now define our list. Celsius in temperature in Celsius is equals to this. That is a list. And then we now come up with a new function that is going to change the temperature from degrees to Celsius, to Fahrenheit. So we begin with this. This is our argument. This is our argument. So we pick each value here, multiplied by 9, divided by 5. And then we add that to. That is our argument. Or even, what do we want to run as our output? What do we want to be our output? If we have a temperature of 20, how do we want to work around with 20 so that we can get that temperature in Fahrenheit? So it will be 20 times 9 over 5 plus 32. And then this is our expression where we are getting the values from. We are getting the values from temperature in Celsius. That is what we are getting our values from. So this is our expression. And then for this case, we've already gotten that. We have to change that into a list. Now, you need to also consider this. We've used filter. We've used map. And just like we said that map is used whenever you want to apply a function to all the elements. You want to apply a function to all the elements. So we use map in this case. And then the output, we change the output to a list. We change the output to a list. So the output would be something like this. And then for C and F in our zips, I know we've not gone through zips. We've not gone through zips, but I believe we are going to go through zips. So this is just, we are zipping the temperature in degrees and their temperature in Fahrenheit. So the temperature in degrees would be represented by C, and the temperature in Fahrenheit would be represented by F. So that is just zipping. So for C and F in the zipped list, in that case, print the temperature in degrees, which is equals to the temperature in Fahrenheit to 1 decimal place. Okay, let us run that. So this is what I mean. So this is just a zipped file. This is just a zipped, not file, but a zipped list. A zipped list. What zip does is that it will just maybe accord a specific value to another value. That is what it does, or even it just, yeah, that is what it does. So that is it. That is it. Now, assume we also want to sort students by grade using Lambda. So assume we want to sort students by grade using Lambda. Now, before I proceed to that, there is something that I forgot to tell you about, which is filter. In this case, in the first example, we used filter because you only wanted to filter out values whereby the threshold is not reached. We wanted to filter out values. That is why we used filter. Now, for the second one, we wanted to use all the values. That is why we used map. Now, for the third one, we want to sort students by grade using Lambda. We want to sort them by their grade. So in this case, we are going to use the sorted function. We are going to use the sorted functions. Okay. So we have the student's name in this case and their scores. So sorted students is equals to, in this case, we are going to have the students. We are going to have our values coming from the students. And then we are going to also have the score, their score from also the students. And then we are going to reverse their order. We are going to equate this order to true. That is, okay. So let me repeat about this. So we have different students. We have Alice, Bob, and Charles. And we want to sort these students by their grade. We want to sort them by their grade using Lambda in this case. So we in this case, we do not have grades. What we have here is percentages. So we want to sort them by, that is in ascending order or descending order. So we want to have the highest value appearing first, followed by the second highest, then followed by the third highest. So in this case, that is why we are having this specific dictionary list, in our case, students. And then for the specific list, we are calling out, or even we are only interested in the score, the student's score. That is what we are interested in. So we compare, or even we sort the scores from the highest to the lowest in this case. When we say that reverse is true, means from the highest to the lowest. If I change this to reverse is false, then what is going to happen is that the values are going to be arranged from the smallest to the largest. That is what is going to happen. The values are going to be arranged from the smallest to the highest. But in our case here, we are going to have the highest to the lowest. So print students ranked by score, and then for students in sorted students, print their name and the score. Print their name and their score. So the first thing is this. We are printing students ranked by their score, and then we now have the students, which is Bob, Alice, and Charlie, and you can see the values are ranked in descending order. If I change this to false, assume I change that to false. Assume I change that to false. Assume I change that to false. You can now see if I change that to false, then the values are going to be arranged in descending order. Not descending, but ascending order, that is from the smallest to the largest. So the reverse is always false when the values are arranged from smallest to the largest. If you want the values in descending order, then you change this to true. And that is it. So what this specific function does is that it just sorts the students and their marks. It sorts the students and their marks. Okay. So the next one, we are to calculate the renewable percentages for multiple regions. And in this case, we are dealing with renewable energy percentages. That is SDG 7 on clean energy. Calculate the renewable percentages for multiple regions. So this is what we have. We have the regions, the different regions. We have the keys and the values in this case. So the percentages would be given by picking this. So we have this specific function. This specific function determines the percentage of renewable energy. It determines the percentage of renewable energy per region. And then the map function here, it is just used to ensure that we include all the values. And then later on, we change that to a list. And then, so after checking their percentages, or even after now calculating their percentages, for region in percentages, print the name and the percentage to 1 decimal place. And then we run that. And you can see for the north, we have 35, for the south, we have 45, and for the east, we have 30. Now, for these specific functions, you'll be dealing with different functions. These are just examples. You'll be dealing with different functions. And how you manipulate them and how you write the codes will also matter. So the only thing that you're supposed to maybe master here is how to come up with the codes. I hope you can see how I'm doing with, or even how I've come up with the codes. first thing we define the list, and then the next thing we now iterate through our list, or even we work with our list for us to be able to maybe get what we wanted to achieve, or even to get to be able to get what we were actually looking forward to achieving. So that is what we do. That is what we are supposed to do. Now allow me to also leave these other examples. They are just a repetition of what we've been doing, just a repetition. Just a repetition. So now this is our last part. This is our last part, and I won't take more than 20 minutes on this. I'll just take us through maybe a breakdown, and then I will do 2 examples, and then we call it a day. So algorithms and complexity analysis. And from our concept of pseudocodes and algorithms, an algorithm is a step-by-step procedure that is used in solving a problem. A procedure that we use in solving a problem. And then complexity analysis measures how an algorithm's performance scales with input size. How an algorithm's performance scales with input size. So I'll just take us through this. So we have different complexity type. For example, we have linear time. In this case, we have linear time. Linear time, it is denoted by that, the big O notation. And what this means is that time grows directly with input size. So as input size increases, time also increases. And that one, it is example of algorithm, or even a scenario. It is majorly used in linear search. And then growth rate description, it doubles when the input doubles. And then performance, as the value of n increases, or even the input increases, it is moderately efficient. And then in this case, what are the notes or the key differences? Each element is processed once. Each element is usually processed once. Then from there, I will take you to the second one, this one, which is constant time. Constant time, the big O notation is this. So this one executes time. Execution time does not depend on input size. So accessing an element in a list by index, or even it accesses an element in a list by index in this case. So that is why we have this. So it stays the same no matter how large the input is. So if you have an input of 100 values, maybe you have a list of 100 values, the growth rate would stay the same no matter how large the input is. And this one is the fastest possible complexity. It is the fastest possible complexity. That is a O1. And this one always performs a fixed number of operations. So that is the O1, and then we have the ON, that is a big O notations. And then we have the logarithmic. But before logarithmic, allow me to take you through the quadratic. From the O1, I mean from the ON, we move to the quadratic. The quadratic. So the quadratic complexity in this case, or even the quadratic time, means that the time increases with the square of the input size. That is why the n is raised to power 2. So time increases with the square of input size. And this one is majorly used in bubble sort and nested loops. And as the growth rate increases, it becomes slow. It becomes slow. This one becomes slow as the growth rate, or even as the input increases. And this one is slow for large inputs. So if you're having large inputs, then this one will be very, very slow if you are using quadratic time. And then the other one is cubic time, that is n raised to power 3. And in this case, time grows with the cube of the input size, the cube, just from the name. And this one is majorly used in 3 nested loops. For example, if you're having matrix multiplications. And then maybe just to mention, we have the other one, which is logarithmic time. Logarithmic time, this is majorly used in binary search, majorly used in binary search. And how efficient is that? It is very efficient for large data sets. So if you're having large data sets, then logarithmic time is very, very efficient. It is usually very, very efficient, mostly in binary search. So this is a summary. This is a summary. We can't cover each and every one of this within the time that we have, but I'll just go through, let me just go through this summary here. So you can see the fastest, it is the O1 notation. And then the one that is extremely slow, it is the O2 raised to the power of n. O2 raised to the power of n, which is exponential time. It is extremely slow. This one is usually extremely slow. And an example is recursive Fibonacci. And then you can see from the fastest to the slowest. The slowest, again, the slowest is On. This one, factorial time, that is always the slowest. It is usually impossible to handle beyond small n, small values of inputs. So we have different types of searches, linear search, we have binary search, and we also have bubble sort, and we also have quick sort, merge sort, and then we have selection sort, complexity comparisons, and a lot more. So let me just take you through the first ones. So we assume we want to search for a student in a list. We want to search for a student in a list. We want to search for a student in a list. So the first thing, we define the function. So we have students and we have target ID. So search for student by ID using the linear search complexity. So the first thing we are going to say for I, that is a student in enumerate. Enumerate is a function, it is a keyword that is majorly used when you want to get the index and the value. The index and the value. So enumerate gives the index and the value of the value within your function. So if you had something like this, just a minute. If you had something like 1, you had 2, you also add 3. So in this case, these are the values. You have 1, 2, and 3. So the index of 1 would be 0. The index of 2 would be 1, and the index of 3 would be 2. So if you use enumerate, enumerate would now output the value and its index. So it's like it searches the value and the index. The value and the index. Okay. So for each value in enumerate, that is students, if the student ID is equal to the target ID, then return I. Otherwise, return this value here. Return that. And then we have a list. We now have a list of dictionaries for the students. And then the result is equal to linear search, this value here, students. And then we are searching for this specific ID. That is what we are searching for. We are searching for ID 002. So let us see what we get as our output. So this one was found at index 1. It was found at index 1. So what this does is that it searches on a straight line. If the first value is not 1, if the first value is not S002, then it moves to the next. If it is not 002, it moves to the third one. If it is not 0, it continues. So it is something that is continuous on a straight line. So the search proceeds on a straight line. So this would be the first value to be searched. If it is not what we are interested in, then the search continues to the second one. If it is not that one, then it proceeds to the third one. That is what it does. So that is a linear search. Linear search. Okay, let me just let me have change that to 4. Let me change that to 4 and see what you're going to get. So you can see in this case, you can see we have different indexes. This is index 0, this is index 1, and index 2. So if the student ID is equal to the target ID, return the I. You return the index. In that case, I is the index. Otherwise, return -1. So you can see what we are getting here is -1. Why? Because this value here is not there. It is not there. It is not there. Okay, let me change that to 2, the third one to 2 and run that. You can see it was found at index 2. This is 0, 1, 2. That is 0, 1, 2. Okay, that is linear search. Then we have binary search. Binary search. Now, assume we want to search in sorted data. We want to carry out a search in sorted data efficiently. And in this case, we are dealing with SDG 9, industry and innovation. So we have industry, innovation, and also infrastructure. So for our case, we are going to also define the function. And then we search in sorted array. That is using the logarithmic complexity. We are going to be using the logarithmic complexity, just like I said, this one. And the one thing that I said about this is that it is usually very, very efficient for large data sets. So input is repeatedly divided, that is a halved at each step. So it divides the input into a halves until it gets the value that is being searched for. So this one actually divides the input into very, very many halves. I wish I was able to add some pictures onto this notebook. I would have, but anyway. So for this case, we have left, right, is equals to 0. Then we have, so this is actually a function that is helping us to carry out a search for a specific function. So assume in our case here, we have a function that has the array and the target. Here's the array and the target. So for our case here, we have the length of the array minus 1. The length of the array minus 1. So if the array, or even if the array has 5 values, so we minus 1. So left, right is equals to 0. Then we have length of the array. So these are values that are going to help us in determining or even helping us in carrying out the search. So while left is less than or equal to the right, so if the left part is less than or equal to the right part, then find the median. MID means median. Find the median. How do we find median? We divide the length by 2. Find the median. And the median will be equal to left plus right. Then we divide by 2 and we floor. This means divide by and floor. You divide by 2. If the answer is 2.5, you floor that to the next number, which would be 3.
Sorry, Musa, somebody raised his hand. User.
Oh, okay.
Hello, somebody raised his hand. User, can you unmute yourself and talk? I'm trying to see if you can talk. No, I think he can only chat.
Okay, let me see what he has to say. If you're not in a position to maybe speak, you can share within the chat.
Please drop your question on the chat. Let's attend to you. User. So you can go on.
Okay. So just like I said, in this case, we are comparing 2 parts. So we've divided the left side and the right side. We've divided the left and the right side. And for this case, if the left is less than or equal to the right, then, while this one is less than or equal to the right, then find the median, and the median would be equal to the left side plus the right side all over 2, and we floor that. Floor, I believe you know the meaning of floor. We have floor. Floor is used when you want to round down in most cases. So we round down whatever we get so that we don't work with decimal places, because you can't have a list that contains decimal places. You can't have a list. You can't have a list whose, I don't know which is the best word for me to use, but in this case, you can assume having 5 values. 5 values. If you pick 5 divided by 2, then you can either have 3 values on the left and 2 on the right, or 2 on the right on the left and 3 on the right. You can't divide one of the values within a list into 2. That is what I mean. So we divide by 2 and then we flow. So if the median is equals to the target, then return median. Otherwise, return. Otherwise, if median is less than the target, then in this case, return left is equals to median plus 1. Otherwise, right is equals to median plus 1. Otherwise, if all this is not met, then return -1. So now we have our sorted data. We have this data here. And then we want the result, or even the result in this case would be the binary search for the sorted data, and the target is 60. We are targeting 60. We want to get 60. So what are we going to do? So print found at index dash. So we want the result, which is now the result of this one. That is what we are looking for, the result. Where did we find our target? So for this one, what I meant is that we are having 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are 9 values. So what Python is going to do is that it's going to find for the median. So median in this case, we are going to have 1, 2, 3, 4, and 1, 2, 3, 4. And those are going to be 2 groups. So we have the left and the right. And then 50 is going to be in between. That is the middle index in that case. It is going to be in between. And then it is going to try to check, to carry out these commands, checking where, or even trying to check the location of our value here, which is 60. And then after getting the position of 50, it is going to return that the index. It is going to return the index. Okay. Okay, so this is median. I changed that to mid. Let me just use mid. So you can see it was found at index 5. So if you count this, is 0, 1, 2, 3, 4, 5. So 60 is at index 5. But now what happens is that it breaks these values into halves, multiple number of times. It breaks the values into different halves, multiple number of times. So it will always find the medium. Like this is majorly repetitive. It will try to divide this into 2 and then find its median and then do the same. And the process continues on and on until it locates our value that we are searching for. That is logarithmic. So that is the difference between logarithmic and linear search. For linear search, we majorly use or even the search is always carried out on a straight line. And for logarithmic search, the search is majorly done using divisions. It divides the values into very many halves. And that is it. Okay. Now, these others, the rest, what we are having here for bubble sort, for quick sort, these are actually like for quicksort, it's majorly like logarithmic, but we usually have some slight changes. Just a minute, let me reload this. You can see it. Okay. Just a minute, I need to. Okay, so just like I said, this is where we were. I believe this is where we were. Yeah, this is where we were. Okay, yeah, this is where we were. So, okay, so just like I said, this is what we had, and I believe I had run this, and we had gotten around 5. Let me just change this to mid. We had gotten, yeah, index 5. So for what we have here is sort, bubble sort, and for quick sort and merge sort, they are really a lot: selection sort, complexity comparisons, and a lot more. So what I'm going to do, you're going to allow me to stop at that. I can see our time is far much spent. 3 hours down the line. Is it 3 hours or 2 hours? I'm not sure. But I'm just going to share with you
2 hours.
specific note. Yes.
2 hours.
I'm going to share.
Thank you.
I'm going to share with you this specific notebook, and then you can just go through it. It has various examples, so many examples, and I tried as much as possible to ensure that I detail, or even I include some comments so that we also know what we are working with. And this is going to help us. These things, they really require a lot of practice. So my advice to all of us, if you need to maybe be comfortable with these codes and also commands and also programming, do a lot of effort. I mean, do a lot of practice. A lot of practice is very, very essential. That is my advice to all of us. Otherwise, you can't master this maybe within a single day. You can't master this on a single read. You have to practice over and over and over. Anyway, so I beg to stop at that. Thank you. Thank you very much for being around.
Thank you, Musa. What a wonderful job you did. What a wonderful job. Can you, MCQ, a few minutes, can we scan through that then? Just give a guide for candidates.
Okay, now concerning the MCQs, I tried as much as possible to see what I can do about it, because you know with MCQs you can't discuss them on open forums like this. But
yeah, okay.
One thing that I can tell you about the MCQs are just about what you've just been doing. They're just about what you've been doing. You come across questions on algorithms and complexity analysis, questions on that is PEPs, and a lot more. They are just about what we've been talking about. So in case you come across any problem, maybe you're not able to solve a specific question, or maybe you don't understand, I can also advise you to reach out to your peers and get assistance, because we are all here as a team to help one another. Yes.
Okay.
So you can reach out to any one of us, including me, and I'll be able to help.
That's good. That's cool. Thank you. That's wonderful. While you are rounding up, I have these thoughts. I think you have a deep knowledge of Python. I think I will request, can you come up with a project that can demonstrate all the functionalities? I'm not talking of a day projects. Maybe you have one that you can share, that why people, as we are rounding up week 4, which talks about the basics and code, as we are moving towards the application of what we've learned. Can you come up with a project, share with us, whereby people can start discussing around it? From there, you can see each of the functionalities that I've been talking about. You can see them in action. What's your thought? What's our view of that?
Okay,
I'm 1 minute. I'm of opinion that Python is not about just learning the syntax. It's like either you learn a French, you learn an English, you learn the grammars, you learn the preposition, but you need to put it into acts by either speaking or you write an essay, write an article, write whatever to capture all you've learned at various classes of the grammar. So when there is a project that's probably narrowed down to everything that you've learned and you see all those things in action, I think it's going to be beneficial for candidates to pick and understand far better. Thank you.
Okay, concerning that, of course, we have different projects, and one thing that I know about Python is that Python is really vast, and it's really, I can say it's really wide. When the world of Python is really big, it's used in various maybe sectors. That is why when I came up with this, I tried as much as possible to just cover most of these SDGs, because all of us work in different sectors.
Mm-hmm.
So, and my advice would be, if you're into health, then we have a lot that we can design about health. You can design maybe a system that tracks maybe the health of patients. And you don't need to come up with something that is really complicated. You start from the basics, from what you've learned. And we have different, we have different websites that contain different maybe projects about Python, and maybe I'm going to share them with us. I'm going to share some of them with us so that we can also go through some of the projects, and then maybe you just choose the one that you're comfortable with, because
Sure.
in life, yes,
Sure.
because in life,
That's a good idea. That's lovely. Thanks.
yes.
Yeah. Guys, how can we make people talk? Use our raise hands. I think you can chat questions as Musa is rounding up. Any question that you want us to look into? I think Musa has done justice to the teaching tonight. He has really passed a lot. He has really crossed a lot of boundary. It's now left for us to go back home, reflect on what we've been learning, and bring them to food. Like I was telling some of us on the chat, programming it could be difficult, but it's not unsurmountable. And when you choose to be here, determination matters. Wrong with determination, wrong with, how do I put it now? Courage and determination matters. And I believe the world is centering around us, data analytics, data science, and we have a lot to offer to the world. And I'm really glad that we are all involved in this. Everything you are doing about data analytics and data science cut across the whole globe today. As long as you interpret either Power BI, either Excel, either Tableau in your language, you are into the world of analytics, and there are voluminous data. There are so many companies that are dying today because they don't even understand the data, the volume of data they have, the in-depth of data they have, the information that sits. It's like somebody that is sitting on gold that does not value because he didn't understand that this is gold. And that is what data analytics is doing for majority of the company across the globe, not in Africa alone. And more so in Africa, we have been laid back for so long. This is the time for us to gear up. This is the time for us to bring Africa to the forefront. This is the time for us to tell China, to tell the world that we are not laid back people, that even this civilization begins in Africa. I want to encourage as many of us to rise up, to fill the gap. There's a lot for us to achieve together. Any question?
Yeah. Hello.
Oh, user. Great. Go ahead.
So I'm Juvent from Rwanda, Alex Kigali.
Oh, nice meeting you.
Nice to meet you too. So I want to thank you, Mr. Musa, for this time sharing how we can code in Python. So I appreciate it. I would like, because on the first lesson, my connection was not good. I would like to ask if you can share with me the link about that session and ask how can I get also this section by the link.
It's actually recorded. It's recorded to be shared. It's recorded. Okay. This section is recorded to be shared.
Okay, thank you. But yes, before also was recorded, but I didn't get a link. I don't know if I am in another group, but we got the link from this session in the group. Should we please get the this recorded link in the group too? Thank you.
Sure, I will talk to some of my colleagues and get back to you on that, but I know it's recorded.
Okay, thank you.
You're welcome. Any other question? Thanks, user. Any other question? So I believe we've all got a lot of information from Musa Peters tonight. That's wonderful. Let's go and reflect on them as we are looking forward to week 5. I encourage, don't lose your guard. Please get a companion, don't walk alone. One of the rudiments of ALS is if you want to go fast, go alone. But if you want to go far, which is important, let people join you. You can run fast, but you will get exhausted on the road. But when you run with people, when you are getting tired, somebody you are dehydrated, somebody will offer you water, juice, wine, whichever. Somebody will massage you and give you courage to move on. So I will encourage you, work with others, and the sky will be a stepping stone. I don't believe sky is the limit. I believe sky is a stepping stone. We can fly across the globe. We are in the right place. We are with the right team. We are with the right people. In absentia or no question, the host, over to you. Host in the house, over to you. Will you drop, Musa, will you drop the notebook on this chat, or you drop it in the group? Which one will you do so that I can pick it and drop for others?
Well, for the notebook, I will share it within the general group. I believe most of us are within the general group, so I will share it there, or even I can also share it within the admin group, and then the admins can share it within the respective groups for the different
great. That's great. That's great. Well done. Thank you. Musa is from Kenya. Am I right?
Yes, I'm from Kenya.
Oh, that's good. Nice meeting you. This is a conglomeration of Africans. I'm in Nigeria anyway.
That is really great. You know, you get to meet different people from different countries, and we all embrace one another. We all grow together as a team. Yes.
Yes. The host in the house, we are through. Over to you.
I think if the class has ended, we can call it a night. Musa, will you mind trying to end the session on your side?
Well, it's okay, but I'm not sure. I'm not sure the person who was recording. I'm not sure that whether the recording will be. I'll
Okay.
be able to access the recording from my side because I'm not the one who started the recording.
I think Cynthia did.
Cynthia, okay, let me reach out to her within a minute and see whether she is around so that we don't end and lose the recording.
Yeah, yeah.
Yes. Hello, Cynthia.
Okay, let me try and reach out.
I think, okay.
Please,